Hey, hope you're all having a good day. My name's Hector. We're going to go over question 41. So, the 1 kilogram physics book in the figure is connected by a string to a 500-gram coffee cup. The book is given a push up the slope and released with a speed of 3 meters a second. Coefficients of friction are the static coefficient of friction is 0.5 and the kinetic is 0.2. So there's two parts. So how far does the book slide, and at the highest point does the book stick to the slope or does it slide back down? So right off the bat, these numbers are important, this is important, and that's important, and so is that. So just kind of looking at what we have, let's start by summing and drawing out our force diagram. So if we go over here, that's not where we want to go. We want to go this way. We can look at the two force diagrams. This bottom one for the book, I've tilted off of the regular axis. We have our normal force. We have our normal force. We have our friction force, our tension force, and of course gravity pulling that book down. The cup is a lot easier system to work with, so we just have that tension and that gravity force, and we can actually solve that out immediately for what tension is, right? So if we imagine the book at rest, this should be what the tension is, right? But really the most important part to understand here is that this T, whatever this T is, and this Fg will be equal to each other, right? That they will cancel basically to zero, because the book will not be, the coffee cup will not be accelerating. And now that we kind of sum the forces for the coffee cup, we have like an idea what tension should be. We can now sum for the book. So if we're summing for the book, we get that the book will be accelerating, right? We've given some push, it's in motion, and it'll be slowing down. So we have our friction force, which is negative, our tension force, which is also negative, and then our gravitational force. So that's the component, the x component of our gravitational force, which is also a negative, and that will give us some some net acceleration, or net force, I should say. So both the book and the cup should have the same A. So when solving for an A, and this is the part that I personally got confused on, you actually want to take all of their forces, right? Because this tension force is going to change based upon if the cup is accelerating or if the book is accelerating, right? They'll have the same A, but the tension will change based upon their acceleration rates. So you have to sum everything up. So that's why we have this, both masses summed here and these terms here. And the important thing I mentioned before is for the cup, these things will cancel out. They will go away. So kind of going through that, we see that if we plug in our values, so this is the continuation of that, we get that static friction, the kinetic friction times n, and it'll get us our A. We can just solve through all this stuff, and then just pump out this value right over here, negative 6.729 meters a second squared. So now we can figure out how far the book actually traveled. So a few ways to do this, but my personal favorite way is just plugging it right into this kinematic equation. The v final squared equals v initial squared. This is just kind of based on the information that was given to us. You could also do the kinematic with v final equals v initial plus acceleration times time. That would require you to solve for a time first, though, and so I just, off the information given, you can kind of just plug this in, and the book should travel about 0.67 meters, which, makes sense. There's way more forces trying to stop it from moving than there are to keep it accelerating that direction. So the next part of the question is, well, does the book slide back down? So kind of going over here, does the cup slide? This should actually say, does the book slide? The cup will also accelerate if the book slides, but that wasn't the question. So summing the forces, we should have that our friction force at the pinnacle at its peak, right? Minus the tension force plus that gravitational force should all be summing to 0, right? So the question really is when is Fs max equal to t plus Fg cosine theta? So kind of going through that, we get that this is what Fs max is. It's this mu times n. That'll be this. It should be approximately this number. So that's our mass of our cup, which is in kilograms now. So 500 grams is 0.5 kilograms. And you have it times your gravity. So this is your Fg cosine, this is your mu, and this is your mass. And since, I mean, we already know that this tensional force from earlier, right? If the cup is at rest, right, the tension would be 4.9 newtons. So if our system has hit the pinnacle, right, it should be, for an instant at least, not moving. And so the tension will be equal to, you know, how we did it earlier, basically summing all these forces up with the cup, and we should get that it's 4.9. So already 4.9 is much larger than 2.3. Adding on gravity to that, we get that the book most definitely slides. And yeah, that's really the whole question. Really, again, the hardest part, at least for me to understand, was his acceleration and why it has to incorporate both of these values. Again, it's just because tension is not, we can't figure out tension because as soon as these start to accelerate, you know, if you think about just as far as the cup's concerned, right, the cup will start moving upwards as the book moves kind of up the ramp, right, which means that this tensional force grows because it's accelerating, right, relative to this gravitation force. So we actually don't know what T is, so it has to all kind of cancel out. So yeah, I hope you all have a good day.